Good morning. My name is Andres Ondo. I'm from Polytechnic University of Valencia. Today, I will talk about redesigning assessment in a power system course under the influence of artificial intelligence. This paper presents an assessment designed for the master level power system and smart grid course at Polytechnic University of Valencia. In this course, students model distribution network with OpenDS. ChatGPT or Copilot can now produce executable scripts, debugging advice, and plausible explanation. This is therefore an assessment inference problem, not merely an artificial intelligence detection problem. A police artifact is insufficient evidence that the student understands topology, assumptions, load flow variables, or the physical meaning of the results. Not single tasks answer the assessment question reliably. The proposed design therefore triangulates three forms of evidence. The diagnostic captures reads nice before artificial intelligence support. The project makes the modeling process and artificial intelligence make decision observable, and the individual oral defense tests whether explanation, transfer, and debugging remain with the student. The unit of judgment is the individual student, even when the laboratory artifact is collaborative. The first layer is a short individual, no artificial intelligence diagnostic, covering per unit reasoning, topology, and load flow variables. It is used formatively to identify support needs. The second layer is an artificial intelligence transparent OpenDS project. Students construct and validate a supplied network case, analyze a perturbation, and document the checks. The third layer is a structured individual oral defense based on the frozen submission. The timings and sample prompts shown here are proposed operational details to be pilot. Artificial intelligence is explicitly permitted, but material interaction becomes observable. Students submit the OpenDS files, assumptions, results, independent checks, a concise technical memo, an artificial intelligence interaction ledger, and a version or contribution trail. The ledger records each suggestion, the accept, adapt, reject decision, the exact modification, and the verification outcome. The oral defense then asks the individual to interpret, justify, and repair. A student who did not use artificial intelligence completes the same common flow code audit task. The rubric operationalizes the four construct name in the abstract. The level 3 means a electrically coherent and independently verified model. Causal explanation with accurate counterfactual prediction, evidence-based audit of artificial intelligence suggestion, and independent diagnosis. Level 2 is competent performance with only minor issues or limited cues. Level 1 is materially weak, superficial, or cue dependent. Level 0 indicate invalid word. Fundamental misunderstanding, acceptance of artificial intelligence output without verification, or inability to critique the common flaw code task, or inability to defend and correct the submission. The 0 to 3 scale and mastery gate are proposed and must be calibrated before deployment. Evidence is integrated criterion by criterion, rather than averaging the three instruments mechanically. Technical correctness is project primary. Conceptual explanation and autonomy are oral primary. Critical artificial intelligence judgment requires the ledger and a common flawed code task. The proposed pilot rule is competence at level 2 or above in every criterion. A project oral gap of 2 level triggers a source second probe or moderated review. A discrepancy is an evidence gap, not automatic proof of misconduct. Administration is standardized before grading. Learning outcomes are aligned with task and rubric descriptors, and students receive artificial intelligence use rule, a sample ledger, and privacy guidance. The diagnostic is followed by target support. The project uses a fixed brief, minimum verification checks, and process checkpoint. The exact submission is then frozen before the structured oral. Difficulty balance prompts, accommodation, assessor answer, moderation, and evidence link feedback, support, comparability, and fairness. For research reporting, consent is separate from grading, and data are minimized and de-identified. The first implementation should test content and response, process evidence, assessor agreement, relationship and discrepancies across layers, and fairness and feasibility. It can establish whether the protocol is usable and whether scoring is sufficiently consistent. It cannot establish causal learning gains without a comparator design. The contribution is therefore an auditable assessment method. When artificial intelligence can generate the artifact, assessment must make the student reasoning visible. Thank you for your attention.